Hello guys, so this is just a quick little stream to update you on what happened since the last stream. So I've been working on, let me just make my head smaller. There we go, down the bottom now. Okay, so I've been working on these two boards. Now last time we saw this board it was massive. The idea was that it would mate onto the bottom of a Nano, and someone, who was it? I have to remember names these days. It's not fair for me not to remember. Someone offered the suggestion that why don't I make it a shield, and actually I didn't think about that, and I really should have done, because it worked out rather well. Let's see, who was it? Who was it? It was Leonid Rusnak. I don't know where you're from, Leonid, but thank you very much for the suggestion, and I did just that. Well, not quite. There's a small caveat to this, in that I didn't make it a shield. I made it to mate to the bottom of the board. Have I got one here? Yes. So it mates to the bottom of the board, because often when I buy these little Nanos, in fact, let's go back to the big face screen. Often when I buy these boards, they've already got the sort of the pins soldered in, and Jesus, are they a pain to unsolder. I don't know why I had to say Jesus there, but I did. So they're a real pain to unsolder, so I thought, why not just make it one that goes on the bottom? I mean, no one says that you have to mount a board like that. You can just mount it the other way if you want to. Still got drill holes through it. So the NRF 24L01 will be mounting that way, and so that's what you see on the screen here. This board is a sideways mounting board essentially, but you just turn your board sideways and mount it on the bottom. So the board sits there. In fact, I've got a picture. I've sent it off to PCBs.io to get printed. It was about, I don't know, $5 or something less than that. Maybe it was, I'm not sure exactly the amount, but it was pretty cheap, and you get 4 copies. So this is the two sides of the board. So you'll see that I've put the little silk screen on here so that I know which way round to mount it. Not that I'll get it wrong, I'm sure. But the DHT22 is down here. I've marked the pins in brackets. We've got the 7 to 12 volts here. That's the volt V in. For the board, so you need to put that much to go through the regulator. 5 volts can go in this way, and ground can go there. So you could power it from an external battery pack if you had one, or a larger pack if you had one there, so that it sort of stand alone. And the LM35 I've marked on here so you know which way round it goes. Now, if you guys want this, I can make it available, but you're probably best to wait until I've received it and I know it works. So hello, Mr. William. So this sort of sits on here, and that's that board, but I've been making some other ones ever since this whole idea about having a proper shield and it not being any bigger than the real board, which I think a couple of people mentioned. I came up with a couple of others because I was thinking about how can I power this, because actually 5 volts is pretty difficult to get from a battery pack. You can get like 4.5, that kind of thing, or 4.8 volts from 4 normal alkaline cells, but you know, oftentimes they're going to be a bit higher than that, or not alkaline, sorry, rechargeable. But when you first charge them, they're going to be higher than 1.2. So actually, you've got a little bit more, and maybe it'll be a bit dangerous, but oftentimes it's not. Still, you want to be able to power it. So I thought, why not create a little boost board for LiPo batteries. So I have designed a couple, so let's just pull one out. You'll see I've got my little Arduino Nano folder here, and I've got some in here that I've knocked up. So this one, I've got the naming a bit wrong, so this one still says NRF, but actually this one is the, let's load that, yeah. Delete lock, I don't know what that means. So this one's based on the L6920DB, or L6920M, so, well that's the package, but it's the L6920DB, which is a little boost converter, and that one will run down to 0.8 volts if you want, but this one won't, because we'll use this LBI pin here eventually to do a voltage comparator thing so that it will drop out at 1.23, but it actually drop out at 3 volts, which will be whatever I have my voltage divider set at. So a bit complicated. There's some kind of equation that goes on inside this chip. So when it gets to 1.23 volts, it will drop. So we have to create a voltage divider from the 3 volts to give us 1.23 when it gets down to that point. Anyhow, this is the board that I've created. So if I just click that little button, I'll be able to see it a little better. Now, it's not perfect. I don't know if it's going to work because the topology of boost circuits can be a little bit dodgy. The problem we have with these kind of things is just where you've got the inductor and then the capacitors, you have to get it quite right. With the L6920dB, actually, it's a lot easier. It's very forgiving. I've used it before. I used it in something I don't have around. I'm going to go and get it. Hold on. I forget that you can hear me when I'm off in the room somewhere because I've got this headset on. Right, here it is. So let's go big full screen. How do we do that? Not full screen, but big circle. Big circle. So this thing, will it focus? Close to. Anyway, we'll say that's focused enough. This thing I made ages ago. It's a horrible prototype. I mean, and it sort of didn't work. I mean, it has an L6920dB, which is just there, and it has a Max 1811, which is a lithium-ion charger chip for single cells. And it had solar cell input here, so it would, well, PV input, photovoltaic cells. So it would charge up a lithium-ion battery through this Max 1811, and then it would boost the battery through the L6920dB. And it had this, it was a poor idea, so just bear with me, but it has an AT-Tiny85 on here and a couple of little displays. Now you'll notice this isn't really the kind of thing I would design now. This was beginner stuff, really. And so it's got a couple of these 74HC595s driving these little displays, and it would give me a number based on the battery voltage, telling me how much capacity I had left. Now it's like 0 to 99, so it's not, it isn't very accurate, obviously, and it would be based off readings I had for that particular battery, so it wouldn't work in all scenarios because I just used a voltage curve that I'd created. Well, I discharged the battery at a specified current output and then mapped that curve in like an array, and then I figured out from there how much capacity was left. So it wasn't perfect, but you have to do that for every kind of battery because they all discharge at different rates. Anyway, it's not good. That's probably why on most battery packs you end up getting this sort of 4 light thing, because generally on a discharge curve of a lithium polymer battery you're going to have those 4 points are going to be relatively similar across all of the batteries. Anyhow, this didn't work, but I've got experience using the L6920dB, and it was a well easy one to use. I mean, look at this thing. This is there are loads of through-hole components here. I used through-hole adapters for the tiny package. I can't remember what it's like, tiny MSOP, or it's got a weird proprietary package for this thing. It's like a TSOP type thing. Is that what TSOP stands for? Maybe it is. I'm not sure. I'm sure someone will tell me. So this one is very forgiving, the L6920dB, which is here. Now this circuit isn't finished, so if you look at this and you go, hang on a minute, he's not done this, then fair enough, I probably haven't. But the Max 1811 will work correctly. This is a well easy one to use. Like, it's literally the easiest lithium polymer battery charger I've ever used. You can also get the Max 1555, which is also similarly easy. I just like the Max 1811 because you can select whether you charge at 100 milliamps or 500 using this celly thing here. So I've shoved it to ground using a 10k resistor, which means it's going to charge at 100 milliamps. Because I think it's a relatively safe voltage charger, I'm likely only to use 1,000 milliamp hour battery on this, so 10 hours charging. And 500 milliamps, depending on what USB port you plug this into, you don't know whether you're going to get it, so it'll just fail at charging. Anyhow, so I wanted to make it so number one, this thing would switch off the L6920dB, which is the boost converter. I want that to switch off when you plug it into a 5-volt power source through the USB. Now, the reason you want to do that is because you don't know what USB voltage you're plugging it into, and if it happens to be lower than the L6920dB can kick out, then you're going to get some sort of backflow issues. And regardless of what it is, you're always going to get these backflow issues, because I'm plugging the output of this, which is, oh, where is the output here? Oh, there we are. I'm plugging it straight into 5 volts. But I'm also using a shutdown pin on 5 volts as well, so that those link together. So a high enables it, and the low disables the shutdown. So there's a little bit of an issue there with how that works. So I've got to look at how I can disable the L6920dB when we get the USB voltage in. So I'll figure that out. What I was going to do is use a transistor to drag shutdown to ground. So when 5 volts goes in, it drags it down to ground. Now the other one that I've picked up, sorry, I haven't read any chat. So I'm pointing at this thing, my head's really big. Hang on, here we go. Let's go back on that, shall we, quickly. So just here you've got shutdown, and this one, it has to be high for it to be enabled. So a high enables the device and a low disables the device. So I need to use something like an NPN transistor and drag this thing down to ground when we get 5 volts in. But I also need it to be high, connected to the output when we want to run it. So shutdown's also connected to LBO, which is the sort of the output bit. So that will, LBO is triggered by LBI. Which is the thing that I just mentioned about the 1.23 volts. This will go into shutdown, so you need a voltage divider across here to BAT+. So that's our battery connection. I've refined this a bit better in the LT1302 design, which I'm going to show you in a second. But again, as I said, this Max 1811 is a brilliant little chip, really easy to use. Literally, those are the components that you need. You don't really need any capacitors. It's advisable, so I've already put them across the battery here. And ideally, you would have one on the input as well. But I figure the Arduino Nano's already got some on its input, so using V-in's not actually a bad idea. So it's just an easy one. Let's jump over to look at the LT1302 quickly. Let's see, where is it? LT1302. Yeah, load all those up. Okay, so this one is a bit more complex because I've got a bit more going on. And so what I decided to do with this one is, similarly to the last one, I've used a switch so that we can turn it on and off whenever we want to. So even if we weren't connecting it to a computer, we can just turn it off. So I'm using this reverse P-channel MOSFET sort of design to do, well, not only does it do sort of polarity protection, but it will enable the battery to go across here, but only when we've got that switched to the battery positive terminal. And so we can switch it on and off here, but if it's also got shutdown connected to V-in. Now the LT1302 will shut down when there's high voltage, but it's usually on when it's on ground, unlike the L6920dB. So this one's much, much easier. So I can connect shutdown to ground with a 10k resistor. Maybe I might go a bit higher than that, I don't know. And then V-in will go directly in and shut that chip down whenever we're connected to USB, which I believe is before, I think it's before, I'm not sure. I think it's connected to V-in. So hopefully it is. I looked at the schematic and I'm pretty sure I'm right, but I'm sure someone will tell me if that's right. Right, I'm just going to have a look at the chat, just make sure I'm not missing anything. So Mr. Williams says you can always use 7805. Yeah, you can, and there's a 7805 on the Arduino Nano, so you can just plug that right into V-in, and that's not a problem. The issue with powering these with using that 7805 is you need about 7 volts to do it, and so that is like a big battery pack, and you want to make it as small as possible. And the reason you do is because these nanos are tiny, so I imagine anyone using a nano wants something in a small package, and they'll also want their battery power source to be in a small package, and so that's why I've sort of gone for this setup where you can power these with a lithium polymer battery and have it quite small. But you can also do it with 2 AA batteries. With both of these setups, if you were to just remove or not use the Max 1811, you just don't populate it, and you could just have the boost circuit and a couple of AA batteries, and it would still shut down when it was connected to USB, and you would have this thing powered from AA batteries, which would work quite well. The L6920DB can supply a bit more current than the LT1302, and the LT1302 isn't as easy to use as the L6920DB. This one requires only a few components, and it comes in a dip package as well, so if you wanted to do through-hole stuff, you can load it up on a breadboard and it's perfect. However, the topology you need for this thing, so the layout on the board itself, I'm not sure if topology is the right word, but the actual layout, you have to be a bit more specific. Noise comes into play here a lot, and so you have to worry about the charging and discharging of this thing, and it can go a bit haywire. And I've tried it on a board recently, not that I can see one around. There probably is one around, but I tried it on a board recently and it didn't work. It was kicking out under 5 volts, not that far under 5 volts, but I was wondering why, and so there's something wrong with the way I set it up. So anyway, this is connected to BAT-SW, that's battery off the switch here. So not only can we switch this one with a physical switch, these tiny little physical switches, I've got to do this jumping back and forth thing, tiny little physical switches, they're SMD ones, and so they're not going to carry a large current. All it's doing is going to the base of this MOSFET. So is it base or whatever? I'm thinking about transistors, but it's a different word. You'll have to forgive me. It's like almost 11 o'clock at night. I can't think really. I just wanted to update you. Anyhow, this design, the LT1302, is done. The L6920DB needs a bit of refinement, I think. And so I will, once I've finished them, I'll get them sent off to PCBs.io because I want to try them out for a little while. I've used OSH Park for a long time now, for like a couple of years. So I thought it would be useful to try these guys out and see how their boards come out. And looking at this, it looks like they're going to be black boards, which looks cool. So hopefully they're going to come out looking nice, and they'll mate well with this, which is also a black board. And if they work, they work. If they don't, back to the drawing board. If they work, you can have them. I'll pop them up somewhere online for you to play around with. And Whisker, if you should watch Voltron. I mean, you just should, shouldn't you? Anyway, that's it. I just wanted to update you on what I've been doing, and I wanted to say thank you for all the suggestions that people have dropped in when I've done live streams. They really do help, and I wanted to evidence that today. So if you guys have got any questions about the schematic or what I plan to do with the thing. Oh, by the way, this you see this big thing here? That's the inductor. And unfortunately, the ones I've got are massive. I say massive, they're not really. I just don't have any SMD ones. So I've got these quite large through-hole ones. I've got a big bag of them. I bought quite a few from Farnell. They weren't cheap, mind, but they're the ones that were recommended in the data sheet for the L6920DB. And it turns out that was the easiest one. I should have gone for the one that was recommended for the LT1302. Anyhow, these are 10 microhenry inductors, and they'll work just fine, I think. But they are big and they're through hole, which makes doing this board a bit more difficult, so I've had to flip it over to the other side of the board in order to make a bit of space. Anyway, I was going, wasn't I? Okay, thanks a lot, guys, and I will speak to you all soon.